Tangents, secants, and angle measures within circles. So there are 6 facts we're going to talk about today. I'm going to zoom in on each one. This first one right here, you can see that we have 2 types of segments. We have a tangent. Remember, a tangent line is on the outside of your circle and it only touches your circle at one point. And here we have a radius. So if you ever have a tangent and a radius touch at a single point, we know that those 2 segments are going to be perpendicular. That will always be true. So we can say that RT is perpendicular to OR. And remember, that symbol means perpendicular. Which means that they form a 90-degree angle. And you can see that in the picture because we see the little 90-degree box. All right, our second fact has to do with 2 tangent lines. So we have a tangent line here because it's touching my circle at only one point. And then we have another tangent line. And then here's the important part. They are coming from the same point on the outside of your circle. If you ever see something like this, you can actually conclude that the 2 segments are congruent. AB, this length, is going to be congruent to AC, this length. All right, our third fact has to do with 2 secants that intersect inside your circle. So here we have 1 secant and 1 secant. It also works, this same fact will work with chords. The only difference between a chord and a secant is that the secants keep going. So if we have an angle here, this is not a central angle, this is not an inscribed angle, so we don't really know anything about them yet. So there is a formula that we can use to find it. So if I want to find angle 1, what I can do is I can take this arc, add them up, and divide them by 2. So angle 1 is going to be 1/2 times arc AC plus arc DB. And you can see that these 3 segments really do go together because if you extend the lines, this angle would go with this arc and this angle would go with this arc. So the same would apply for angle 2. We can say angle 2 equals 1/2 times AD plus arc CB. Angle 2 equals 1/2 times arc AD plus arc CB. Now let's look at a scenario like this where we have a secant line and a tangent line which are intersecting outside of our circle. So here this actually helps us to find this angle, angle A. And for problems like this, we can say angle A equals 1/2. So it starts the same, but this time we're going to do 1/2 times your larger arc, arc DC, minus your smaller arc. So in this case, it will be 1/2 times arc DC minus arc BC. So this same rule really is going to apply for 2 tangents. You can probably guess just by looking at it that angle A is going to be 1/2 times our larger arc, which is DE, minus our smaller arc, which is BC. And once again, we are subtracting. And the last scenario is if we have 2 tangents. So here, it's going to be the same exact setup. So here we're going to have 1/2 times our larger arc, which in this case we need 3 points to name. So we can say B, D, C, arc BDC, minus our smaller arc, which is arc BC. But the same idea or the same concept always applies. It's going to be the angle equals 1/2 times large arc minus small arc. So those are really the 6 important facts that we'll need to know about secants and tangents in circles. Okay, let's try applying some of these rules. So here I see that we're going to use the rule where we actually add up the two arcs and divide it by 2. But if you notice, the arcs that we are given to work with are here and here. Now that is going to go with the other angle. So that's actually going to match with one of these angles. So I'm going to call this x. But if we can find this angle, I notice that I have a straight line right here, which means I should be able to find angle 1 by adding them up and setting them equal to 180. So first let's find x. We can say the angle equals 1/2 times 38 plus 46. Remember, this is the one time where we're adding up the two angles, or the two arcs. So x equals 1/2 times 84. So x is going to equal 42 degrees. And then once again, I see that we have a linear pair. So I know that angle 1 plus x, which is 42, should equal 180. Remember, because we have a linear pair, a straight line. So all I need to do is subtract 42 from both sides. And I can see that angle 1 equals 138 degrees. Now I'm done. So notice that we kind of have to work our way over to angle 1. We can use the formula to find a different angle, and then we can use that angle to find angle 1. All right, let's try another one. Here I can see that we have a secant and a tangent intersecting outside. So I'm going to do that the angle equals 1/2 times our large arc, which we know to be 100 and, right here, we know to be 128. And then I'm going to subtract it from our small arc. But the problem is we don't know the small arc measurement. So that's going to be the first thing we need to find, and I'm going to label it y. So I know that the angles in a circle should add up to 360 degrees. So I can create an equation and solve for that y value. So I'm going to combine like terms. So we have 276 plus y, and then we can subtract 276 from each side. And here we should get 84 equals y. So from here, now that we know our small angle, we can use our formula. Outer angle equals 1/2 times large angle minus small angle. So x is going to equal 1/2 times 44. So x will equal 22 degrees. All right, so here we have another similar problem where we have the outer angle, and we know that it will equal our large arc minus our small arc, which once again we don't know. So we're going to need to find that first. But you might notice that we do know that this is actually making a semicircle because we have a diameter which goes through the center. So this is exactly half of a circle or a semicircle. And we know that the angles of a semicircle should add up to 180 degrees, half of a full circle. So we can say 180 equals 52 plus 84 plus y, and we can combine like terms here and we get 136 plus y, and then I can subtract 136 from both sides and we get 44 equals y. So now that I know my small arc, I can use the formula we just learned. Outer angle equals 1/2 times large arc minus small arc. So x equals 1/2 times 40, which is 20 degrees. Okay, our last problem we're going to do is a little bit tricky. So here we're actually given the angle and we want to find one of the arcs. So we can still use those same formulas. We're going to do angle equals large arc, which we know to be x minus small arc. Now, we have to find some way to describe this small arc. So I know a full circle is 360, and I know this is x. So I can describe the small arc as 360 minus x. It's essentially a full circle minus the part we're not using. So I can still create that same equation using the formula we know, even though both of our arcs have x's in them. So we say the outer angle, which is 55, equals 1/2 times large arc minus small arc. And it is really important that you have those parentheses because we have to actually distribute the negative. So now we just have to solve for x. So like I said, we'll distribute that negative. So minus 360 plus x. And now we can combine like terms. So 2x minus 360. And let's distribute. So 2x divided by 2 is 1x. 360 divided by 2 is 180. And then we'll just add 180 to both sides. And we get x equals 235 degrees. All right, that's all for today's lesson. Thank you for watching.